The first person that we're going to award is to give AFAR's Honorary Leadership Award to Ned David. And this award recognizes achievements of individuals and organizations whose work has impacted aging research and improved public health. So I'm going to read this now because I don't want to get anything wrong. Ned is president of United Biotechnology, which he co-founded in 2011. Before establishing Unity, Dr. David co-founded 4 other biotechnology companies that together raised over $1.5 billion in financing and employ over 400 scientists, engineers, and business people. Dr. David is co-founder of Syrinx, subsequently acquired by Takeda, Acoagen, Kythera Biopharmaceuticals, subsequently acquired by Allergan, and Sapphire Technology. He holds pending and issued patents across a broad swath of areas relevant to human health, such as nanotechnology, crystallography, antibacterials to avoid antibiotic resistance, aesthetic medicine, and methods for eliminating senescent cells. He served on the board of the directors of Kythera Biopharmaceuticals, Sapphire Energy, and the Buck Institute for Research on Aging, and is a member of the Board of Trustees of the University of California Foundation. So please join me in welcoming to the stage to receive AFAR's Honorary Leadership Award, Dr. Ned David.
Thank you very much.
Let's just set it here.
Sure. Can you guys hear me? All right. So, when we're kids, we're told that when you're given some sort of distinction or award, that the thing you're supposed to say is that you're honored and that you're humbled. And whenever I hear people say this, I often wonder how much of that is authentic and how much of it is good social training. But what I can say about this today, for a very particular historical reason, that not only am I honored, but I am humbled to the point of actual embarrassment. And that is due to the fact that were it not for AFAR and its far-sighted vision going back 3 decades, Unity in its current form, or perhaps not at all, would not exist. And so it's a little bizarre that I'm getting an award for something they did, okay? But I think it actually speaks to a larger story, what AFAR chose to do, and its long-sighted vision, and what it means for the future, as opposed to just the past. And I want to talk to you guys a little bit about that today. But before I get there, I have to talk about someone very special to me. This is Judy Campisi, okay? Yes, by the way, she looks like an all-around tough person here, but I swear she's this extremely sweet, cuddly human being. And she's been my scientific colleague for the last 6 years. And what most people do not know about Unity when they hear the story and what we've done is that it really goes back to Judy in the 1980s. And the narrative, of course, is that, and it's not a particularly well-documented time in Judy's life, she had just been coming off of her folk music career. Now, I requested specifically access to photo documentation of this period, and I was told that these images were, quote, destroyed. Okay, so I managed to come up with this. In fact, that's not Judy, but I guarantee they are folk singers. And what I do know about that period of time in Judy's career is it was characterized by VW buses, tambourines, and a significant amount of cannabis. And what followed this, of course, was Judy going to BU in the 1980s, Boston University. And it was in the 1980s when AFAR more than 30 years ago, gave Judy $50,000. It was the first money she'd ever received to study the impact of senescent cells on aging. And it was this money, which seems like just a little bit, but 30 years ago it was enough to generate enough data to get her first NSF grant, which gave enough data to get her first NIH grant and her second NIH grant. Flash forward 30 years, and we now have an entire field birthed by long-sighted vision and $50,000. Now, just so you guys all know what we do at Unity, so that this all has context, I'll just briefly tell you what we're up to here. So at Unity, we care about what most people in this room care about, which is how come as we age, we get more disease and we have a decrease in our quality of life. Well, not uniquely to us, we tend to think about aging as a phenomenon, as the product of a constellation of mechanisms that work together to create the overall phenomenon you think of as aging. So things like stem cell failure, things like direct metabolic control as seen manifest through things like calorie restriction, things like loss of circulating youth factors, molecules present in the blood of the young, which when perfused into the old confer features of youth. Then there is the big unknown, the actual resident space of the ticking clock that we don't know what it is yet, the thing that makes us fundamentally different from 20 to 40 to 80. And then there's cellular senescence. Now, we at Unity have focused on cellular senescence over the last 6 years, not because it is the only or even most important aging mechanism. We don't think it is. But we focus on it because of all of the aging mechanisms identified to date. It is the most druggable, and it's druggable for a simple reason. At conception, you're a single cell. As you age, this cell, you, can divide as many as 50 times, and as it approaches 50 cell divisions, most cells in your body will stop dividing forever when they encounter some form of cellular stress. And we refer to these cells as senescent cells. And this emergency braking system is a super important anti-cancer system. You don't want to mess with it pharmaceutically, because we know if we disable this emergency brake system genetically, mice are born normally but wind up full of tumors before reaching reproductive age. So nothing we propose to do at Unity pharmaceutically messes with the braking system. We leave it intact. However, as all of us age, these arrested senescent cells accumulate in our bodies. And so my son here, who's 8, has no detectable senescent cells, whereas my stepfather, who died at 87 from Alzheimer's, was full of these cells. And before the work of 2 people sitting here, Judy, who I've already mentioned, and Jan van Derzen, sitting right next to her, no one knew if these accumulated senescent cells were good for you, bad for you, or neither. And so what Judy and Jan did is each of them constructed special genetically engineered mice that allowed us, for the first time, to selectively eliminate senescent cells from mice and get to ask the question, what happens? And this is what happens. So these mice are siblings, born within seconds of each other from the same mom. And to give you a sense of their age, these mice are the equivalent of a 70-year-old person, assuming you were a mouse. Now, this guy on the left is blind, osteoporotic, frail, kidney dysfunction, cardiac dysfunction, generally not doing well. Its littermate on the right lives on average 35% longer, but we think that's the boring part. The really important part, we think, is that its littermate has a profoundly extended period of time that we call its health span, the duration of time this animal lives free of many of the conditions plaguing the animal on the left. And what we're doing at Unity, based on Judy's work going back 3 decades, is we're making drugs that will do that. Now, I'll just show you a few of these cool things that happen when you eliminate senescent cells that we haven't published yet. These animals are courtesy of some of Jan's work when we eliminated senescent cells, but then The data generated is courtesy of Simon Melov from the Buck. These are animals, the skeletons of animals, with and without senescent cells. And if you look at the skeletons of these creatures, some surprising phenotypes leap out. So this is looking down the central axis of the femur, which is the longest and strongest bone in all of our bodies. And what you see is that the animal from which we have deleted senescent cells, its femur is 25% thicker. And if you look at the inner wall of the animal that's got senescent cells in its femur, it's pitted out like the surface of the moon, suggesting that by a mechanism we do not yet understand, senescent cells are dissolving your bones. Now, we also then, from these same mice, looked at their vertebrae. So one of the great indignities of age is back pain and the gradual loss of the intervertebral disc space. So we looked at what happens to mice when, over the arc of their lives, from midlife to old age, we eliminate senescent cells. Again, these were courtesy of Jan's work. And what we saw was that the intervertebral disc volume was 41% larger in the animals from which we deleted senescent cells, suggesting that not only are these cells dissolving your bone, they're dissolving your cartilage. So I'm going to show you a cool experiment that Jan did. This is Jan and Darren Baker at the Mayo Clinic. These mice are siblings, and it's obvious from looking at these guys that they look different. The question is, how do they behave that's different when you eliminate senescent cells? And so Jan and Darren did this experiment where they put these mice in a box. It's called an open field study. And you put a camera on top of this box. And you record the motion of these animals for 15 minutes and see what they do. So if you guys have never seen data from this before, these are two traces from such an experiment. So this thing on the left, where that pink line is squigging all over the place, looks like a 3-year-old with a crayon. That is the path of a young mouse running around. On the right, and this is kind of depressing, okay, that is a somewhat older animal. And what you see is that this animal moves a lot less and also does not, for reasons that it will not share with us, like the center of the cage. So Jan did an experiment in which he eliminated senescent cells during this animal's life. And what you see is in the equivalent of a 30-year-old person, if you were a mouse, okay? If you look on the left there, this is the equivalent of the 30-year-old person, total motion in 15 minutes. Fast forward to a 45-year-old person, pretty depressing, huh? But if you eliminate senescent cells, what you see is that statistically you preserve motion like that of a younger animal, even though this is an animal that's now in midlife. But I think even cooler than just running around is willingness to explore. And so what you see is the same trend is true. The equivalent of the 30-year-old animal will explore the center of the box. As you age to middle age, it explores about half. But if you eliminate senescent cells, this is an animal that explores like a young creature. Now, I doubt we will ever have an FDA approval path for wanting to take up a new musical instrument or going camping. But this effect, I think it's the most profound of the phenotypes we've seen because it speaks to the gravity of the biology that we're able to perturb. Now, what does this all mean to medicine and pharmaceuticals? And what does it mean for what we've been able to do with AFAR's long-sighted investment 30 years ago to today? Well, this is Unity's corporate strategy on a single slide. And for those of you not used to looking at this stuff, what it depicts is the drugs we're going to be developing over the next 3 years. And what we've been able to do at Unity is harness the underlying insights of Judy and Jan to create molecules that eliminate senescent cells from all of us. And we're going to go into a series of different clinical programs in our joints for osteoarthritis, in the back of our eyes for things like macular degeneration or diabetic retinopathy, and be able to ask this question 3 to 4 times in a human being in the next 3 years to ask, does the elimination of senescent cells impact a human disease of aging? Now, everything we are doing at Unity for the next 3 years is focused on asking that essential question. Does the elimination of senescent cells take an inescapable aspect of aging that we've all accepted and we were told as children we're going to face? Does it take that feature of aging and make it a treatable medical condition? Well, we are going to ask that question. And if we technically succeed, and I hope and believe we will, this moment will arrive when that's no longer in the future, but it's in our past. And at that moment, everything begins to change. We now are in an era in which we can take insights into fundamental aging mechanisms and perturb them with drugs. And I think that this insight really traces itself back to the beginning. When AFAR in the late 80s gave Judy this $50,000 grant, flash forward 30 years, now we've been able to raise over $160 million to ask and answer this question. That's some serious leverage. And I'm here today not only to be very humbled by the fact that AFAR created this opportunity for us, but also to ask every one of you guys, if you can, to team with us and AFAR financially to try to do this again. Now, to understand this request, I think there's a useful metaphor, which is a tree. Now, I use this metaphor to explain the aging research field. Pretend you were a group of aliens. You came to Earth for the first time. You'd never seen a tree before. Everyone divides up researching. Some work on the leaves, some study stems, some study branches, some studies trunk, some might even study the roots. Well, I think the aging field, each of us working in these various areas, even the most self-important of us, are probably at our best days studying stems or perhaps thick branches. Very few of us are actually studying the trunk or the roots. And I believe in the coming decades, that is where things radically change. And when I think of this chart I showed earlier about these disparate mechanisms, and I think about the big unknown, where the actual ticking clock lives, what I'm hoping to ask you guys to do is pitch in, support AFAR to do this. Make small grants to young researchers so that we get to do this not 1 or 2 times, but how about 5 more times? 5 entirely new mechanisms on top of senolysis and the other areas, because that would be a pretty awesome future. Anyway, I want to thank AFAR for this honor, and I really want to thank AFAR for making Unity possible. Anyway, thanks very much.
Thank you.